Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 416. Partition equal subset sum. Okay, so given an integer array nums, return true if you can partition the array into two subsets such that sum of elements in both subsets is equal, or else just return false. Okay, so this is what a prompt statement. So for this, you want to first know about what is meant by subset, right? So subset is something like we want to delete some element from our main array so that it will be the subset of the given array. Okay. For example, if the given array is 1, 5, 11, 5, then I can tell 1 and 5 is one of the subset, or 1, 11 is one of the subset, or 1, 11, 5 is one of the subset, or 1, 5, 11 and 5. So whole thing is one of the subset, or empty set is also one of the subset. Okay. But you cannot have a subset like 5, 1 because 5 is occurring after 1 only, right? So you should remove all the elements, but don't change this order. Okay, so that's going to be your subset. Fine. Now see this example. For this 1, 5, 11, 5, I can take 1, 5 and 5 as one of the subset and 11 as one of the subset, such that both sum will be equal. 11 is equal to 11, right? Okay, fine. Now here 1, 2, 3, 5. Here whether I can partition them into two kinds. No. Here itself we can return false, right? Because you cannot do like if you take 1, 2, then it will be 3, whereas other thing will be equal to 8. If you take 1, 2, 3, then it will be equal to 6, but other thing is 5. Okay. In commonly we can tell like if the sum of the array divided by 2, okay, gives me a remainder. Okay, if I divide the sum of the array divided by 2, which gives me the remainder as 1, okay, then I'll be telling that hey, it cannot be further divided, right? If else I want to go and check whether we can form or not. Can you understand this? So the basic logic will be, first of all, I want to check whether sum divided by or sum mod 2 is equal to 1. Then there itself I can return false. Else I can go and check whether it is true or false. Okay. How we are going to check? Whether we can use a greedy algorithm? No. Always remember, for these kinds of questions, we cannot use a greedy algorithm because we cannot predict which element we want to take or which element we should not take, like that. Okay. So whenever there is a confusion in the greedy, then we want to go for a recursion. We want to go for all possible combinations. Okay. So how we are going to do this in a recursion? So if you don't know about the recursion, just go and watch my recursion introduction video. I'll be giving that video link in the description. Go and watch about recursion tree, recursion stack, and how recursion works, the DFS approach. Okay. So these three things will be more important to understand this problem. Okay. Fine. So to construct the recursion, I want to have a function, right? So the function should have what are all the parameters. So the function should have where I am currently standing, whether I am standing at 0th index or 2nd index or 3rd index, or I reach to the end. Okay. So I want the index. Okay, index. Come on. Anything else I want? Yes. I want like I'm going to partition them into two parts, right? Two parts. So I want to find sum divided by 2. Sum divided by 2, which means here, what is the sum here? It is 11 plus 12, so 22, right? So divided by 2, which is equal to 11. So I want to check any one of the subset is equal to 11. Then obviously the elements which are remaining will be equal to 11. For example, if I remove this 11, okay, if I remove this 11, then what is my sum? It is 22 minus 11, which is equal to again 11, right? Can you understand this? So I'll be taking my sum divided by 2 as a target. So I'll be sending this target also. Can you understand this? How this target is formed? Yes. So see here, I want to split them into half. We can frame this problem like that also. Instead of taking like we want to take a subset and another subset and we want to check for their equality, instead of thinking like that, think like that. We want to just split them equally. That's it. Can you understand this? So to split them equally, we just divide by 2. That's it. Okay, that's the reason why target is equal to sum divided by 2. For example, if the given array is like that, like this, then the sum divided by 2, the target, which is equal to 11. Okay, fine. Now without delay, we can just go into this problem. So try to understand this, because this is going to be somewhat trickier than the remaining recursion problems. Okay, so see here, initially I will be starting from 0. Okay, and what is my target initially? My target will be 11 initially, right? So let me take the example. So this is our example. So what is the sum divided by 2? It is 11, right? So that's the reason why here also it is 11. Okay, fine. Now, how I am going to split this problem? At first, I am standing at this point, right? At this 0th index. So whenever there is a subset problem or subsequence problem, we'll be telling like what? We can either take it or we don't take it, right? So see here. So I want to split this array into 2 parts, which is equal to this 11, right? So I may consider this one in one of my part, or I may not consider this one in another one of the part. Okay, so if I don't take, not take, then how my recursion going to be? Don't do anything, just move on to the next index and keep the target as it is. If I take it, I want to check whether this 11 is strictly greater than this one, strictly greater than or equal to 1. Okay, so if it is greater than or equal to 1, then only I am going to do what? Go to the next index and subtract 1 from 11, so which is equal to 10. Now hope you understand how these two are framed, right? Now again here also again I have not take and take. If I not take, don't worry, just go on to the next thing, okay, and here it will be 11 remain as it is. Okay, if I take it, I want to check whether this 5 is greater than, is strictly lesser than or equal to 11. Yes, it is strictly lesser than or equal to 11, right? So in this condition, I can go to the second index and subtract 5 from the 11, which is equal to 6. Okay, here also I have not take and take. Can you understand the intuition, right? So if it is not take, then it will be 2, 10. If I take it, then it will be like f of 2, 5, because I am subtracting 5 since 10 is greater than 5. Since 10 is greater than or equal to 5. That's the reason I am just subtracting 5 from that. Okay, and I am taking that value. Can you understand? Whenever we are taking, we want to subtract from the target and we want to check. Before subtracting, you want to check whether it is a valid thing or not. Can you understand this? Okay, see here, if my target is less than 0, then subtracting any values to it will be remains less than 0. That's the reason why I'm checking whether it doesn't go beyond the 0. It should be always in a positive way, or can be in a 0, right? So you can understand after completing this entire recursion tree. Okay, so here again it will be not take and take. If I don't take it, it will be remains as 3, 11. If I take it, it will be like something like f of 3, so if I take this 11, I want to check whether this 11 is lesser than or equal to this 11. Yes, it is equal to, so take it, so it will be 0. Now here also I have not take and take. If I not take, it will be like 3, 6. If I take it, it will be like 3, here it is 11. Now you can understand. Here it is 11, right? Can I take it? Not, because 11 is greater than 6. So I cannot take it. So I'll be just doing what? I'll be just returning false. What it indicates? It indicates, hey, you cannot go apart from that. You came to the end, so it will be returning false. And understand this? Okay. Now here again, not take and take. Okay. Now not take. So not take means don't worry, just go to the next thing. Take whether this 10 is greater than, the target is greater than or equal to the current element. No. At this condition, what I am going to do? I just return false. Okay. Similarly here also, I have two conditions. One is not take, another one is take. If I don't take it, don't worry, just move on. Or if I take this 5, this 5 is the target, which is lesser than the 11, right? Strictly lesser than the 11. So I cannot take it. So it will be 3, sorry, it will be returning false. Okay, fine. Now again 3 comma 11, 3 comma 11. Here also I have two conditions. One is not take, another is take. If I don't take it, don't worry, just move on, just move on. So 4 comma 11. Let me just save it so that in future my laptop maybe anytime it will be struck. Okay. Okay. Now if I take it, it will be like f of 4 comma. First of all, I want to check whether I can take it, right? So third index is what? 5 only. That's the reason why I am just taking it. Okay. So 11 minus 5, which is equal to 6. 6. Take 6. Okay. Now here I want you to understand another base condition. So this base condition, what is this base condition means? It means target is 0, which means we have some subset. We came across the recursion call and we have some subset which is equal to 11, which means if I take that subset alone, then the remaining subset will be equal to that. Then at this time I will be returning true. Can you understand this? Why I am returning true here? Yes. Okay. Let me go and continue. Here I can either not take or take. If I don't take it, it will be f of 4 comma 6. If I take it, it will be f of 4 comma 6 minus 5, which is equal to 1. Okay. Here also similarly, I can either not take or take. If I not take it, will be 4 comma 10. If I take it, it will be f of 4 comma 5, because 10 minus 5 will be 5 only. Okay. Now here also not take and take. Okay. If I not take, then it will be f of 4 comma 5. If I take it, I want to check whether this 5 is greater than or equal to the current element 5. Okay. So because the current element of industry is 5, right? Yes. So what I am going to do? 4 comma 0. I understand this. Okay. Now see here, it is 4. 4 means it reached the end. Okay. So since it is reached the end, but our target is not equal to 0, we are just returning false. Here also return false. Here return false. Here also return false. Here return false. Here also return false. Here also return false. But here it is reached the end, but our target is equal to 0, which means here I want to return true. Okay. Now in my left recursion, it is returning false. In my right recursion, it is returning false. So what should I take? I should be taking false. So return false. Similarly here also return false. Here also. So here comes the crucial part. So see here it is false, but here it is true. So if any one of them is true, then I can tell you there is one possibility of having the subset, the equally partitioned subset, right? So here I will be taking as true and returning true. Can you understand this? Okay. Now come back. So here it is false, but here it is true. So we will be taking true. So return true. Here false. So return false. Here it is false. So return false. Here it is true false. So return true. Here it is true false. So return true. Here it is false true. Return true. Then here it is true. So I will be returning true only. So true is going to be my output. Can you understand this? Okay. So what is our simple step is, first of all, we want to find out what is the sum of the array. Then if the sum can be divisible by 2. If it is not divisible by 2, then there itself I can tell you it is false. We cannot divide it by 2. Okay, then how can I partition them as 2 parts, right? And if it is divisible by 2, then I want to just go into the recursion calls such that I will be taking any element and not taking any element in my subset, such that if any one of the subset is valid, then I can tell you, hey, we have formed one subset which can be one of the partition of the main array, such that its sum and the remaining part sum will be equal. So it is going to be my answer. So I will be returning true. So always remember, in a recursion or in any problem, okay, if they are asking in a question, if they want the length, or they want any values, or they want a sum, or they want a maximum, or they want a true or false, then don't go and just try out all other things. Okay, here in this question they are asking us to find the true or false, that alone. they don't want us to return the subset. Okay, so you want to just think away like I only want either true or false. So what is going to be the logic behind it? Instead of go and just generating the subset. Okay, hope you understand this. Now tell me, what is the time complexity? So the time complexity will be in a worst scenario, it will be 2 power n cross, so just a minute. Yes, so n is going to be the size of the array, and target. So target going to be sum divided by sum of the array, sum of the array elements divided by 2. Okay, now what is the space complexity? It is O of n cross target. Can I understand this? So this is going to be a time and space complexity analysis. Okay, so let us see the code. So I have written the Java code. If you want a Python or C++ code, just go and find in the description. So see here. So this is going to be your main function. Sorry. This is going to be the main function. In the main function, first of all, I want to take the sum of the array, right? So here in these 2 lines, I have took the sum of the array. Now I want to check whether the sum can be divided into 2. Okay. If my sum or 2 is equal to 1, then I will be surely returning false because I cannot divide it into 2 parts. See here, the sum itself cannot be divided into 2. Then how possible the array can be divided into 2? So that's the reason why I written false. That's it. Okay. If not, what I should take? I should take the index as 0 and target as sum divided by 2, such that I will be go on just subtracting the subset value in the target. If at any particular point my target is equal to 0, then what should I do? Just return true. That's it. Okay, so that's the core logic. So see here it is going to be the recursion function. Here what are 2 varying parameters? It is I and a target. Okay, now if target is equal to 0, then I will be returning true. Okay, if I is equal to the array dot length, which means came to the end, then there I will be returning false. Okay, you may ask, hey, in some scenarios we have saw. In some scenarios, the array length will be equal to, the I is equal to array length, but at the same time, target is also equal to 0. At that scenario, first of all, this line will be executing. Then only this line will be executing, right? So at that case also, it will be true. Can you understand this? Okay. Now, pick is equal to false initially. So what is the condition to take it? So condition is, if my target is greater than or equal to the array of I, the current element, then only I go and pick it. Can you understand this? Otherwise, don't pick anything. Pick will be false there itself, right? See here, already my target is gone to the negative value. Okay, take for example, my target is gone into the negative value. Then what is the purpose? What is the purpose of again and again doing a subtraction operation on that variable or on that value and expecting to be a 0 at some point? It will be not becoming a 0, right? It is impossible. That's the reason I am checking at first itself. Then only I am picking it. If I want to pick it, then what should be my recursion call? It will be I plus 1 and target minus the current element. Okay. If I don't pick, don't do anything. Target will be same, but go to the next in this. Now at last, any one of them true, then I will be returning true. Okay, that's going to be the valid path, right? So any one of them true, I'll be returning true. So this is going to be your entire recursion function. Okay, now let me take this. We are next getting into a memoization technique. Okay, so before getting into the memoization technique, I want to teach you why we are using it and what is memoization, right? So second one is memoization. So we will be storing the result in the memory such that in future we will be just using it to avoid the unnecessary time taken. Okay. For example, we can go here. So is there any 2 functions which are same, like 2,6? There are also 2,6 like that. That's nothing like that. Okay. In some scenarios, in some other scenarios, like when you are going for a bigger 3, here you will be having 2,6. Same thing will be occurred in future also. But here itself you will be computed its value by going down for all this recursion call, right? Because recursion is a DFS. If you already saw my recursion introduction, you can understand that. Okay. So there itself I just computed its value. So again, when I reached here, Again, why I want to go all down? Instead of that, if I store this in my memory, when I again founding that it is again repeated, then instead of going down, I'll be directly returning from my memory, right? So that's going to be the memorization technique. So memorization technique can be done in two ways. One is hash map, another one is array. So I strongly recommend you to understand the array concept, so that it has many advantages, and also I want you to try the hash map concept after watching my array concept. Okay, I'll be teaching you the array concept, then you can go and try the hash map concept. And hash map is going to be very simple, but it has a disadvantage, like we cannot further optimize anything, but in array we can further optimize, right? Okay, so let us get into it. So there are some set of rules. The first rule is we want to construct the array. For constructing the array, we want to check for its dimension. So how we are going to find the dimension is, what are the varying parameter here in the recursion function. So there are two varying parameter, one is I, one is target. Okay, so that is if I can tell you, we are going to construct a 2D array. Okay, fine. Now what is going to be the value of I and what is going to be the value of target? So that's going to be the second part. Okay, so what is going to be the value of I? So I will be starting from where? Will be starting from 0 and going up to array.length minus 1. If it goes to array.length, then it will be returning false, right? So it will be going up to what? Up to array.length minus 1. So which means it will be n size. So n is going to be the size of the array. Okay, n cross. So what is the target value? So target will be starting from, so see here, target will be starting from sum divided by 2 and going up to where? Going up to 0. If it reaches the 0, then I will be returning true, so that it will be reaching up to 1. It will be reaching up to 1, which means target will be having a maximum value of +1, target +1. So this is going to be the size. Which means, for example, if you are taking the same array 2, 5, 11 and 5, okay, then I'll be having like, so it will be like a lengthy thing, but I'll be just giving you a short thing. Okay, so see here, what is the length? Length is 4. So in row you will be having 4 rows. Okay, but in column, see here, what is the target? It will be sum divided by 2, which is equal to 11, right? Which is equal to 11. So you'll be starting from index 1, 0, 1, 2, 3, going up to 11, which means you have 12 columns. Can you understand this? So this is your next step. Okay, now what is the next step is, you want to fill all the values. So filling the initial value is going to be somewhat tricky, but here what are the two possible values I can get? I'll be getting either false or either true, right? So I will be getting either false or either true. So you can either fill them everything as null. Null is not going to occur anytime, right? Anytime in the recursion function. It will be not in a return value. So null is not going to be the return value. So I will be initializing everyone as null. Okay, I will be telling you why we are going to initialize like that. Okay, now that's it. So these are two base condition. Now I want to add one more base condition, like if, so take for example, it is dp. Okay, if dp of I and target, okay, is not equal to null, okay, then what should I do? I just return dp of I and target. Can you understand this? That's it. Okay, so this one line you want to add, and another one line is before returning anything. So here at line number 10, okay, I want to add one more thing. Instead of returning like this, dp of I and target is equal to pick or not pick. Okay, then return it. Return dp of I and target. Okay, so what are these two lines are representing? So let me highlight here. So these two lines are representing like, hey, you will be updating the dp array. You are updating the dp array, and these two lines are representing what? Hey, you are just trying to check whether it is already computed. If it is already computed, then don't do anything, just return there itself instead of go on checking for the recursion call. if I don't put this base condition, then these 3 lines will be executed, right? So if these 3 lines will be executed, then our time will be not saved. So by doing this, our time will be saved, and my time complexity will be what? O of n cross target, and my space complexity is what? O of n cross target. So the time is vastly reduced, right? Vastly reduced. So these are 2 types. One is because of the matrix we have used. Yes, another one is because of the recursion stack. Okay, now we are next getting into a method called optimization step called tabulation, which will be eliminating this recursion, and we are just going into a looping. Okay, I'll be telling you that. Before that, we just go and watch that coding path. Okay, then we can come back. So see here, this is going to be a coding path. So see here, first of all, I declared the DP array, okay, the matrix. Then what is the next line? I am going to just change. So here one more base condition. If the current index is not equal to the null, then I will be returning that current index value of the DP. Okay, and then another value is here. Before returning any values, I want to update that value on the particular DP, that particular index. Then only I want to return it. Okay, similarly, what is going to be the DP size? It is going to be array.length and target plus 1. Why target plus 1? Because target is also occurring, right? Target is also occurring here. Okay, if 11 is the target, then 0 is not occurring, but 11 is occurring. So I must have an index called 11. That's the reason why I am putting here as target plus 1 as a one of the dimension. Okay, apart from that, everything is similar to the recursion. Now, let me take this. Okay, then we can go for a tabulation technique. So tabulation technique is quite difficult than the memoization technique. Okay, but I'll be teaching you with understanding. Okay, fine. So the third one is tabulation. So tabulation is nothing but we are just converting the recursion code into a looping code such that this recursion stack is eliminated. This one of the space is eliminated, right? So it is purely a looping. For this, we want to follow some set of conditions. Like, first of all, we want to check for the any updated or updation or any modification in the array or matrix we have initialized already. So here, what is the matrix I have used? So here I have used a matrix of n cross target plus 1. N cross target plus 1. Okay. Now I want to check for the base condition to check whether I want to modify any dimension or any values in the matrix. Okay, so let me draw the matrix. For example, if there are 3 numbers, like 4 numbers, like 2, 5, 11 and 5. Okay, this is what they have given, right? Or 1. Okay, so this is what they have given in the problem, right? For this, what is our matrix that we have designed in the memoization? It is like 0, 1, 2 and 3. Meanwhile, here it is 0, 1 up to what? Up to 11, which is 12 columns. So 4 rows and 12 columns what we have designed in the memoization. Now see this base condition first. So in our base condition, if my target is equal to 0, then what should I return? I should be returning true, which means in my target 0 means this 0th index make all values as true. Okay, everything are remaining as null only. Here alone I changed as true. Okay, apart from that everything is null. Okay, just imagine like that. I cannot draw that. Okay, it will be taking much time. Okay, now if I is equal to ARR.length, then I will be returning false. Okay, but whether I have anything which is row is equal to ARR.length, which means I have any 4th index for the row? No. See here, what is the length here? It is 4. So I should have another row. Such that this row where I is equal to 4. Can you understand this? So now how my dimension is modified? N plus 1 cross target plus 1. Can you understand this? So this is how I modify the array, and also I have modified my values inside it. Can you understand this? Okay. Now for here I want to take it as true. Okay, that's nothing. Can you understand this? Fine, because here this is going to be executed first thing. Okay, then only it will be executed. That's the reason I am taking this as true. If it is in a reverse fashion, then I will be taking this false. Just understand. Just understand. See here, I have reached my end, and also my target is equal to 0. Then whether I am taking that as a true or false, I'll be taking that as true, right? That's the reason here also I am taking that as a true. Now can you understand this? Yes. Okay, fine. Now what is the next step? Next step is always eliminate this line. Always eliminate this line. Fine. Now what is the next step? So these are going to be my body of the recursion. These are going to be my body of the recursion. Whenever I encounter the body of the recursion, put a for loop. Put a for loop. So for. So here comes first of all I. Okay. I will be from where to where. So here I will be starting from 0, right? Starting from 0 and going up to where? Going up to array.length. Array.length. Okay. Then array.length -1. Then in tabulation, it will be in a reverse fashion, like it will be starting from array.length -1 and going up to 0. Just do a reverse fashion. Similarly, for my j, okay, I'm taking a j, okay. Here also, where it is starting and where it is ending. It is starting from the target and ending at 0. Okay, ending at 1. See here, ending at 1. So similarly here, it will be starting from 1 and ending at where? Ending at target. Can you understand this? Can you understand this? So target is equal to what? Sum divided by 2. Sum divided by 2. Can you understand this? Just do a reverse fashion for the tabulation. Now what is the next step? What is the next step? Next step is write these 3 lines into somewhat modified lines, like pick is equal to false initially. Okay. Now what is the next line? If my target is greater than or equal to my current in this element, okay, then what should I do? Pick is equal to here it is a recursion call. The solve is a recursion call. Whenever there's a recursion call, instead of that, just write our matrix. And what is the varying parameter we have? I plus 1 and target minus ARR of I, right? So here also write like I plus 1 and then target minus ARR of I. That's it. Can you understand this? Can you understand this? Similarly, write the next line. Next line is not pick. Not pick is equal to, so solve means recursion. So instead of recursion, you want to write dp of I plus 1 and the next one is target. That's it. Okay. At last, after completing this entire for loop, at last, what should I return as an answer? So here what I am returning as answer, it is 0, target. So here also you want to write like dp of 0 and target. Okay, so this is how we will be converting a memorization code into a tabulation code. And tell me what's the time complexity. So time complexity will be n cross target. Okay, and space complexity will be also n cross target, but it is because of the matrix we have taken, not because of the recursion stack. So this is going to be your code for the tabulation. So see here, everything are same up to these lines. Okay, these lines. The only difference I have done in the next line is n plus 1 is remain same. Sorry, target plus 1 is remain same, but n plus 1 is alteration I have made. Okay, and then what the next thing I want to make? So the first column of every row should be equal to true, because whenever my target is equal to 0, I want to return true. That's the reason I made here also as a true. Okay, now what is the next step? Do a reverse fashion. So I will be traversing from n minus 1 up to 0. The index will be traversing from n minus 1 up to 0. Meanwhile, my target will be starting from 1 up to the target. Meanwhile, in recursion, it will be starting from target up to 0, where 0 will be the base condition. So it will be going up to 1. So that's the reason why here also I have made that change. Okay. Now, rest of them will be same as I mentioned in the drawing explanation. Okay. At last, I will be returning the dp of 0 on a target, since we have returning here also as 0, target as a last thing. Okay. So this is going to be an entire tabulation code. Now let me just copy this. So this tabulation code will be more helpful for us to get into the next optimization technique called space optimization. Okay. So what is mean by space optimization? So we want to delete the unwanted space. That's it. Okay. For example, See here. So this is going to be our inner loop, right? For inner loop, the I value will be not changed for one iteration, for one entire iteration, right? So for that entire iteration, I only need what? dp of I plus 1 and j, which means dp of I plus 1 alone I want, that individual row alone I want. Okay. Similarly, here also dp of I plus 1, the only single row is want. Here also dp of I is what I want. So from here I can tell you we only want two rows and target plus 1 columns. Can you understand this? So let me take here next. So next will be represented as dp of I plus 1. Okay, and dp of I will be represented as current. So just a naming convention, that's it. Okay, you can name anything you want. Okay, dp1, dp2, that's your wish. Here I just put like next and current, which will be somewhat meaningful. Okay, now next will be what? Will be of one row in which it have target plus 1 column, okay. Meanwhile, in its first position, zeroth index, the value should be what? The value should be true. In my zeroth index, the value should be true. Everything else will be having a null or false. That's your wish. But the first value should be always true. The zeroth index value should be always true. Similarly, for the current also, it will be starting from zeroth index. It will be going up to what? Target as my last index, which means target plus 1 column. Okay, here also I will be having as a true at first. Okay, now so instead of this one line, I have made these two lines. Okay, now this line we can skip it. Okay, instead of that only we have initialize here as 0 and here as true and here as true in the zeroth index. Okay, now just put these two loops. Okay, when I came to this line, okay, not pick. So not pick will be of dp of I plus 1. I plus 1 means next. So next of j. Okay. Similarly, this line also same and this line also same, but this line will be differing. Like pick is equal to dp of I plus 1, which means next. So next of j minus arr of I. That's it. Okay. Now this line will be differing because dp of I and j. So whenever dp of I occurs, we want to change into current. So current of j is equal to pick or not pick. Okay. Similarly, after returning, before returning, we want to do one more thing. So see here, in this last time, after completing this entire loop, I'll be changing like the next will be updated as current. That's it. Okay. At last, what should I return? I'll be returning my either next of target or current of target. That's going to be your wish. Okay, that's it. So this is going to be your entire alteration to make a tabulation into a space optimization. So what I have done here is, so please just carefully observe this so that you can understand this clearly. Okay, follow my white color mark. Okay, so see here, initially I'll be taking 3 and 4 as a two rows. Okay, then at the next iteration for I, okay, then I'll be taking these two rows, 2 and 3. In next iteration I'll be taking 1 and 2. In next iteration I'll be taking 0 and 1, like that. I understand this. It is like I'm taking only 2 rows and going upward, such that I don't want any of its below values, right? That's the reason why I am just space optimizing it. If in some cases some problems will be not having these features such that it cannot be further space optimized. At that point, the tabulation is your optimized solution. Okay. Now tell me, what is the time complexity? It will be n cross target. Meanwhile, my space complexity will be only of O of target. Can you understand this? So this is going to be a time and space complexity analysis. Now just remember what is the time complexity in the recursion and what is the time complexity in a space optimization. Fine. Now let us get into the coding part. So see here, so this is going to be a coding part. So entirely will be all similar as what I wrote there. So here it is a next. Okay, so here I have made next as a non-local variable. Meanwhile the current is a local variable for the outer for loop. Can you understand this? Okay, that's the reason why at last when I am returning, I cannot return current of target. If you wrote this current at here, if you declare here and initializing at this part, then it is hopefully fine. Then it is hopefully fine. Can you understand this? Yes. So these are the changes I want to make such that I will be ending up in the space optimization technique. Hope you understand this, right? If I submit it, yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. And if you have any doubts, then just comment below. I'll be commenting on the answers. Okay. And also don't be demotivated after seeing the DB questions, because many DB questions cannot be solved at the first try. You want to never give up and just try again and again. Okay. Thank you.